Imagine a printing press so precise it can draw lines the width of a single DNA strand on silicon. There is only one company on Earth that can build it. ASML's EUV machine is the ultimate gatekeeper of the modern economy. But this monopoly is an illusion. ASML does not build this machine alone, they assemble it from 100,000 parts sourced from thousands of global companies. We are told that decoupling will secure Western technology. But the physical reality of ASML's supply chain proves that true decoupling is a chemical and mechanical impossibility. Welcome to East of Wall Street, where we dissect the unseen dynamics driving global power and finance. Deep in the Brabant province, ASML's Veldhoven campus is the undisputed capital of the semiconductor universe. Here, thousands of engineers assemble the machines that shape the modern world. Every advanced smartphone, supercomputer, and artificial intelligence model relies on silicon processed here. The EUV machine uses extreme ultraviolet light to print nanometer-scale transistors onto silicon wafers. No other company on Earth can build these machines. Yet, Veldhoven is not a self-contained fortress. It is an assembly point. If a single logistics hub in the Netherlands or Germany shuts down, ASML's entire delivery schedule collapses. This vulnerability is the core choke point of the digital age. Inside the Veldhoven cleanrooms, the mechanical scale is staggering. The EUV machine requires a temperature-controlled environment where a single speck of dust can ruin a multi-million-dollar wafer. Engineers in protective bunny suits assemble these systems with surgical precision. To print features at the nanometer scale, ASML had to redesign the physics of light. Traditional deep ultraviolet light was too wide to print modern transistors. ASML spent decades and billions of dollars developing EUV lithography. They pushed the limits of materials science and quantum mechanics. The result is a machine that operates at the edge of physical possibility, making ASML the ultimate gatekeeper. To understand ASML's absolute dominance, we must look at the market share. ASML controls 100% of the global EUV lithography market. There is no competitor. Neither Nikon nor Canon, who dominate older lithography markets, can build EUV systems. This monopoly gives ASML unprecedented power over the global technology sector. TSMC, Intel, and Samsung must place orders years in advance. A single delay in ASML's manufacturing pipeline halts the expansion of advanced fabs worldwide. The semiconductor industry has accepted this total dependency as the price of technological progress. But for national security planners, this concentration represents a single point of failure. Behind this monopoly lies a deeper truth: ASML does not manufacture most of its machines' components. They source them from a highly concentrated network of suppliers. In Germany, the Carl Zeiss Group spends months polishing the mirrors that direct the EUV light. These mirrors must be so smooth that if they were expanded to the size of the United States, the largest bump would be less than a millimeter high. Physics dictates that only Zeiss can build these optics. If the Zeiss factory in Oberkochen experiences a fire or a strike, global advanced chip manufacturing stops. This dependency proves that ASML's monopoly is actually a chain of sub-monopolies. This hyper-specialized triad consists of ASML, Zeiss, and Trumpf. Zeiss provides the optics, while Trumpf builds the high-power CO2 laser. These three companies have worked together for decades to solve the engineering challenges of EUV. They have aligned their research, patents, and manufacturing processes. No other group of companies can replicate this ecosystem. Rebuilding this capability in the United States or Asia would require trillions of dollars and decades of training. The triad has created an industrial moat that is impossible to cross. But it also means that a failure in any single node of this German-Dutch alliance cascades instantly through the global technology sector. To organize this complexity, we must examine the specific suppliers. Zeiss manufactures the mirrors, Trumpf builds the laser, and Cymer, based in San Diego, builds the light source. ASML acquired Cymer in 2013 to secure control over the tin droplet generator. This generator vaporizes 50,000 tin droplets per second with a laser to produce EUV light. Reconstructing this precise process requires high-precision engineering that cannot be easily duplicated. The three suppliers form a tight choke point. Without any one of these companies, the EUV machine cannot be built, locking the global supply chain in a state of extreme vulnerability. The engineering constraints of the high-power laser are immense. To generate EUV light, the laser must hit a falling tin droplet twice. The first hit flattens the droplet, the second vaporizes it into plasma, emitting EUV light. This process must run continuously inside the machine. The laser itself must maintain extreme stability under intense heat. Trumpf's laser systems are engineering marvels, but they are also highly delicate. They require constant maintenance and custom replacement parts. If Beijing or Washington restricts the export of laser components, the maintenance of existing EUV machines would grind to a halt, disabling fabs across the globe. This vulnerability has turned ASML into a primary target of the tech war. In recent years, Washington has pressured the Dutch government to expand export restrictions. Under these regulations, ASML is prohibited from shipping EUV and advanced DUV machines to Chinese customers. Beijing has responded by investing billions in domestic lithography, led by state-backed firms like SME. But without access to Zeiss optics or Trumpf lasers, Chinese firms remain generations behind. The technological blockade is absolute, forcing China to attempt to replicate a 3-decade-old German-Dutch ecosystem. This struggle highlights the limits of national industrial policy. The geopolitical standoff has created a system of managed vulnerability. Tech executives and national security analysts agree that true decoupling is a fantasy. The United States cannot build an independent semiconductor supply chain without ASML, and ASML cannot build its machines without German optics and American software. The global tech economy is not a collection of independent hubs, it is a single, interconnected machine. Governments that attempt to build domestic walls will only make their own industries more fragile. The race for technological sovereignty must navigate this web of mutual dependencies. At the nanometer scale, sovereignty is a physical impossibility. The silicon wafers that power our AI models and guided missiles are the product of global cooperation. The transition to advanced nodes requires the integration of Dutch assembly, German optics, and American design tools. No single nation can control this entire pipeline. The illusion of self-sufficiency has led to billions in wasted subsidies. True security lies in managing these dependencies, not trying to break them. Companies and nations that accept this reality will lead the next technological era. If you want to understand the real financial and geopolitical forces driving the global economy, follow East of Wall Street. Subscribe now to our channel. The next briefing is already in the works, where we will examine the critical mineral choke points in Africa and the future of electric vehicle battery supply chains. Our team of analysts tracks the data, the policies, and the physical trade routes that shape our world. Do not get left behind in the new era of tech nationalism and trade blockades. Click the subscribe button and turn on notifications to receive our briefings as soon as they drop. Thank you for watching, and stay informed.